So look at the sum. There's a block and a B block, and A block is 1 kg block and the B block is 2 kg block. The A block and B block. There's a velocity of 16 meter per second with which A is already moving, which is initial velocity of the A block. There is a coefficient of friction that exists between the two blocks, which is 0.4, and therefore the 16 meter per second will reduce as it starts moving, because the coefficient of friction will pull down the A block and will accelerate the B block in such a way that the momentum of both the blocks are equal. So MA into VA is equal to MB into VB. Momentum are equal. MA is 1 kg, MB is 2 kg, hence you get VA is equal to 2 times VB. அப்படிங்கிற relationship கிடைக்குது. Upper, let's calculate the acceleration of the top block, which is because the top block should not slide over bottom block. It has to pull the bottom block with it, which means A is equal to mu into G, which is 0.4 into 10. So 4 meter per second square is the acceleration of the top block. Once you know that, you can say VA is equal to UA plus AAT, which is 16 meter per second, minus acceleration is minus 4. Because you know why it's negative? Because the final velocity will be lesser than the initial velocity. So that makes sense, right? That this will not strike anybody. That is the problem here. Logically we have to think, okay, now let's go to, now I got this equation 2. Let's find the velocity of the bottom block, which is UB plus AB into T, and UB itself is 0. Initial velocity of bottom block is 0. Do you know the acceleration of the bottom block? You don't know. But what is responsible for pulling the bottom block to the right is the frictional force, correct? The frictional force towards the right direction in this case, because it has to drag the bottom block with it, and the friction is what is pulling it with it, and so then the frictional force direction is like this. And how to find the frictional force of the top block and the bottom block is what is providing the frictional force, which is mu into normal reaction. Mu is 0.4, normal reaction for the top block alone is just 10, so 4 newtons is the frictional force of the top block on the bottom block, and that 4 newtons can be divided by the bottom block's mass. So the 2 meter per second will be the acceleration. It will be positive in this case because from 0 it's accelerating. So this VB is equal to 2T. You already know in this first equation, instead of VA you can write 2 times VB is equal to 16 minus 4T, because VA is 2 times VB. That's the first equation that we got. And VB itself is 2T, so 4T is equal to 16 minus 4T, thus 8T is equal to 16, hence T is equal to 2 seconds. It's very difficult sum for me. Let's go to next sum. The block of mass is 2 kg rests on a smooth floor. When an iron cylinder of mass 25 kg is placed on it, the floor yields. Floor abdi break aayi abdi ulla podhu irangudhu. The block and the cylinder moves down with an acceleration of 0.1 meter per second square. What is the action of the block on the floor? Okay. So initially the floor is not yielding because there is only the 2 kg block. The 2 kg block, when placed, the downward will be mg and the upward normal action will be r, and r will be equal to mg, which is equal to 20 newtons because 2 into 10. But the moment the cylinder has been placed, the total weight is going to change. It's 27 newtons, 27 mg, because you have a big cylinder which is getting placed, 25 kg cylinder. So 27 will be the mass, and there will be an mg, and there will be a normal reaction. You can consider this to be one block with 27 kg with mg and normal reaction, and you know it's going to yield, and the acceleration of it is 0.1 meter per second square. It's going to yield down. So this is mass into acceleration will be downward force. 27 into acceleration will be the downward force. Yeah, and so let's write the this new normal reaction. We can call it as r dash or whatever, mg minus r dash. Mg minus r dash will be responsible for mass into acceleration. So mg minus ma is equal to r dash. So mg is nothing but 270 minus ma is nothing but 27 ma into 0.1, which is 270 minus 2.7. So if you see here, I would have done a mistake. I had not written this equation on the right side. Can you see? I have written r dash is equal to mg plus ma. It's wrong. Okay, please correct it. How will it, without subtraction, how will it become 267? 0.3 Newton. So please correct that part. Okay, so that completes the sum. So let's go to next sum, which is the 13th sum. So then there's a mass m1 and there is a mass m2. The question is about contact forces. Okay, smooth surface, two blocks are always in contact. What is a contact force? You know, the force applied is F. Let's find the acceleration, which is A is equal to F by m1 plus m2 is the acceleration of the entire block. Now therefore you know that since this is acceleration, you can multiply this with m1. That will be the actual force on acting rightward on this block, on the first block m1, force on that block, which means there is an F and there will be a contact force. This is F and this is contact force, and this contact force, suppose it is some X force. Okay, so then I have to get F minus X should be equal to m1 into F by m1 plus m2. So I am going to consolidate F minus m1 F by m1 plus m2. I am just trying in front of you. Okay, I may go wrong in the sum. So when I take F here, m1 plus m2, it will be m1 plus m2 minus m1. So m1 get cancelled, it will be x, and then this contact force itself is F into m2 by m1 plus m2. You understand how I did that? Yeah, I found the acceleration of the entire system, multiplied that with mass m1. So I get the force with which the mass m1 is moving towards the right, which means the net force, some contact force subtraction on F will give me the net force. So F minus an unknown force X will give me this force. Consolidate, get the value. Beautiful, correct? That's, and contact force will be equal and opposite. How much ever the contact force is m1 on m2 will be equal to m2 on m12. So irrespective, it's not going to change. So let's go to next sum, which is the 14th sum. An insect is crawling up a fixed hemispherical ball of radius capital R. Again radius capital R. I think we have seen hemispherical sums. Okay. If the coefficient of friction is 1 by 3, then the height up to which the insect can crawl. So the insect is going on crawling, and come here. Say the insect is going to be here. The moment it's going to be here, the normal reaction is like this, and the mg is going to be downward, and the frictional force, say friction on irukradnal da adu kizha villa. So the friction therefore is acting on this direction, and that friction is what is responsible for it to rise up in this case. Okay, so this is where the frictional force is, mg is, the normal reaction is. And okay, I should have drawn the normal reaction properly because I should join it with the center. So this is the normal reaction.